Hello, my name is Jerry Woodall, and I'm going to show you something really spectacular today. We have learned how to make aluminum split water into hydrogen and aluminum oxide or aluminum hydroxide. As most of you know, you can use aluminum for lots of things like boats and pans, and the reason you can do this is that aluminum, even though it's a high energy material, has a protective oxide on it called aluminum oxide or alumina. Because of that oxide, aluminum itself is very stable. But if we were to remove that oxide, that aluminum would react with water instantly, forming hydrogen and aluminum hydroxide or oxide, depending on the environment, whether it's air or water. I have figured out a way of getting rid of that passivating oxide by dissolving the aluminum in a liquid element, gallium, and we're going to walk you through that video. So here we go, aluminum gallium water to hydrogen demo. In the scene here that you see, we have a crystallization dish made of Pyrex. It's sitting on a hot plate. It's got 1 kilogram of gallium in it and 25 grams of aluminum, which is the solubility limit of aluminum and gallium at about 100 degrees C. We're heating it so that the aluminum will dissolve faster than if we just let it sit there. It would dissolve, but we're going to accelerate that process. In the center of this disc, which you will see in a moment, there is a stirrer to help with convection, make the aluminum dissolve even faster. So here we go. You can see the aluminum bubbling around because of the stirrer causing that action. Okay, this is 15 minutes after the start. The aluminum is rapidly dissolving into the gallium. The stirrer is still going, but it only takes 15 minutes in this particular example. Normally, if we were to put in smaller chunks of aluminum like BBs, it would go faster. So we have these slugs that weigh a total of 25 grams just to show that it's dissolving into the system. Notice that what was pure gallium before now has aluminum, and the aluminum in the gallium tends to wet the crystallization dish. So after 30 minutes, the aluminum is completely dissolved to its solubility limit. We will turn the stirrer off, and then we're going to add water. So there she blows. There's our hydrogen generation, bubbling like crazy. 25 grams of aluminum will make 33 liters of hydrogen, so it makes a lot of hydrogen. It'll use up all the aluminum that's dissolved in the gallium, so it's 100% efficient in dissolving all the aluminum and converting it to hydrogen. 8 hours later, after we completely reacted all the aluminum in the gallium, we are left with, on the top, an anhydrous gel, if you will, of aluminum hydroxide. You can see some bubbles, voids in this aluminum hydroxide due to where the hydrogen was bubbling before. Below it, there's some water, and below that is the gallium that we started with. So we put this into a chemical hood where we're withdrawing air from the hood and the surrounding area. So this mixture is evaporating the water from the aluminum hydroxide, and so what we're left with this beautiful powder, 5/9 purity aluminum hydroxide. Even though you can't see it, there's still gallium on the bottom and a little bit of water in the bottom of this, but the aluminum hydroxide has dried very nicely. Finally, we take the aluminum hydroxide alumina and dry it out to alumina, and then we put it into a Hall process where we do electrolysis to take the aluminum hydroxide and aluminum back to aluminum so we don't lose anything, and the gallium is completely inert and it's completely recovered. Once you buy the aluminum, it's yours forever, and once you buy the gallium, it's yours forever.